Good morning, and you may not be watching this in the morning, it might be good night. But this is section 2.4, day 1. A couple of things we're going to talk about today is average rates of change and instantaneous rates of change. We're also going to write equations of tangent lines and perpendicular or normal lines. And writing lines you've done since Algebra 1, at least. And average rates of change, we actually did with speed in the first section of this chapter, but now we're going to do it with any type of rate of change, whether it be temperature or change of just anything besides speed that changes rates. Okay, so we have a couple of definitions to look at, and then we're going to do this example, x cubed minus x on the interval 1 to 3 to find the average rate of change. Okay, so the average rate of change, let me write this down. So the average rate of change is defined by the change of a quantity over the change in time. Mathematically, we look at it with this equation, and you might recognize that. That's a slope equation. The average rate of change is a slope between 2 points. So let's look at our first example, which fancy wording for finding the slope between 2 points. Now these are our 2 points. And by the way, this is an interval, not a point, between 1 and 3. That means we're looking over here on the graph, we're looking at x equals 1 and x equals 3. We're looking at the rate of change or the slope between those 2 points on that curve, okay, between 1 and 3. So we're going to take the function at 3 minus the function at 1, which are the 2 y values, and then take the 2 x values. I'm going to call this m average. This is the average rate of change or the average slope. Okay, this function at 3 is equal to 3 cubed minus 3. And then we're going to subtract 1 cubed minus 1. And then 3 minus 1 is 2. Therefore, we get 27 minus 3. 27 minus 3, which is 24, minus 0 over 2, and that equals 12. Our average rate of change for this function, this cubic function, is equal to 12. It's basically the slope. Now, the slope between 2 points in a curve is also called a secant line. Hopefully you learned that in geometry, because I'm not here to teach you about secant lines. This is called the average rate of change. And then what we're also going to talk about is instantaneous rate of change. It is the slope of the line tangent to the curve. Okay, so this is the m tangent. This is the m secant, or you could also call it the m average. And this, the slope of the tangent line of a curve, is also known as a derivative. That is the quantity for a derivative. And we don't actually learn that right this minute, but it is. Okay, so the secant line is the slope equation we're used to between 2 points. The tangent line is when you only have 1 point. And so if you want to find the slope of that tangent line, but you only have 1 point, who are you going to call? Well, some people call Pierre Fermat, and his picture's gone. Hold on. There he is, good old Pierre. Pierre came up with a way to find the slope of a tangent line at a point. And many things back then all of a sudden became correlated together because this was really a derivative. What he came up with is he said, here's point A. What if we picked a point right next to point A called A plus H? H is a teeny, teeny, teeny small number that if you add it to A, you're right next to A, but not exactly A. And let's find the slope between these 2 points, between A, x equals A, and x equals A plus H. And now we can find the slope of a tangent line, or at least get very, very close if we do it that way. Okay, so let's take a look at how we do that. So we're considering this function 2x squared. Let me move this. So we're considering this graph and this function, 2x squared minus 1. We have it graphed over here. And we're considering it at point x equals 2, which is right here. I have it marked on the screen. The point is 2, 7. And you can actually plug 2 into this f of x equation and get the fact that the y value is 7. So we have a point. And remember, we're going to also want to write this equations to lines of curves. So we need a point and a slope. We've got a point. In order to write the normal line, we're going to have to write the slope of the tangent line at x equals 2. So here's how we're going to do that. We're going to take point A, which is 2, and we're going to take point 2 plus h. And we're going to find the average between those two. So, and then we're going to take that limit as h goes to 0. As h gets very, very, very small, what happens to that slope? So we take f of 2 plus h minus f of 2 over 2 plus h minus h. And, well, those two are going to cancel out. So, I'm sorry, this is 2 plus h minus 2. Try that again. Therefore, your 2's cancel out, and you're left with just an h in the bottom. This is actually the equation we use. So now I've added this general equation. By the way, this is also the equation for the derivative of a function at a point. So you might want to keep that in mind too. I don't know that they really mention that here. Okay, so if we take our function 2x squared minus 1, and we're going to plug in 2 plus h, and we're going to plug in 2. And then we're going to take the limit as that h goes to 0 of this. So we have 2 times 2 plus h squared minus 1 minus 2 times 2 squared minus 1 divided by h. Now there's several steps to this. Looks a little algebraically fun. It's really not that big of a deal. You have to FOIL 2 plus h times 2 plus h. This is 8 minus 1, which is 7. Okay, divided by h. Okay, we're still on part A, figuring out the slope of the tangent line. As I said, this is a little bit of algebra in it. 8 plus 8h plus 2h squared. I'm distributing the 2. Minus 1 minus 7. Notice that 8 minus 1 minus 7 cancels out. That type of thing happens in these equations. And let's just look at algebraically. We have 8h over h plus 2h squared over h. I distributed that denominator. We end up with an 8 plus 2 h's. Because these h's are going to cancel out, and one of those are going to cancel out. So now we have the limit as h goes to 0. When h goes to 0, we're left with 8. Therefore, 8 is the slope of the line tangent to the curve at x equals 2. So let's use that information and what we already know to write the two tangent lines. We know that our point on the curve is 2, 7. We know that m equals 8. It's a very simple job to write the equations of lines. We're going to use point slope form in this class all the time. Okay, so this is x, this is y. I like to do that so I don't mix them up. Equals 8 times x minus 2. That is the tangent line. Part C says give me a normal line. Now remember, a normal slope is negative 1 over 8, inverse reciprocal. So this equation of line is going to be negative 1/8 times x minus 2. The last step of this problem tells us And by the way, this is the normal line. And this guy right here was the tangent line. All right, the last step says draw the graph, which I did, with the two lines. Okay, right here at x equals 2, this is 2, that is your tangent line. Right here is your normal line. Okay, the slope of the normal line, slope tangent line. All right, so tangent and normal, that's what they want you to do, draw the graph from the two lines. All right, next example. This says, determine, this is a little bit different. You have to do problems 15 to 18 in your assignment. Well, that's part of it. And you have to determine whether the curve has a tangent at a point. So I'm going to do one of these problems with you. And this is problem number 15. It's a piecewise function. It says less than 0, the function equals one thing, and greater than 0, the function equals another thing. So what we have to do in this case is we have to say that the limit as x goes to 0 plus equals of this function, and we have to say, in order to show that it's continuous, because that's what it's asking us, does it have a tangent at the indicated point? That means it has to be continuous to have a tangent. So the limit as x goes to 0 minus, and that has to equal the function at x value, or at 0. Or I should just say at 0. Okay, so we have to have these three things equal. Keep that in mind on all these problems. All these things have to be equal. If they're not equal, you don't have to do this second part. You don't have to give the slope. Now, if they are all equal, then you do have to find the slope of the tangent line, which you will have already found because it'll be this number that you're adding up. Okay, so the function at 0 right here is 2x plus 2. So you plug in a 0, and your slope right here is 2. I'm sorry, your function value is 2. Next, you have to take these two limits. X from the positive side is here. This is 0 positive. Less than 0 is 0 negative. So let's take the limit as x goes to 0 from the right-hand side, which is the positive side. And actually, we're taking the function at 0 plus h minus the function at 0 over h. And in this case, let's give ourselves some more room. Our function is going to be 2x plus 2. Okay, so 2. All right, so this limit as x goes to 0 from the positive side equals 2 times h plus 2 minus 2. And therefore, we have 2h over h, right? Because the 2's cancel out. 2h over h is just equal to 2. That is our right-hand limit. Let's put that one in there. So far, we're good, huh? Now we need to check the left-hand limit. Coming from the negative side, this one's going to be just a teeny bit more algebraically intensive, because we're going to put f of 0 plus h minus f of 0 over h. And our equation's just a little bit fancier. 2 minus 2 times 0 plus h minus 0 plus h squared minus this whole thing, the function at 0, which is just equal to 2, right? The function at 0 is equal to 2. And so, divided by h. All right, so we have 2 minus 2 h's minus h squared minus 2. This one, the 2's cancel out. And we distribute our h, negative 2h over h minus h squared over h. And we get negative 2 minus h. We take the limit as x goes to 0 from the negative side, and this goes to 0, we get negative 2. Uh-oh, the left-hand slope is not equal to the right-hand slope, which is not equal to that. So the curve does not have a tangent at x equals 0. Okay, so I have it. That's problem 15. That's how you do those problems. Here are a couple hints for your homework for problem number 7, problem number 8, and also this talks about 15 to 18. So have fun.